welcome to calculus. All right? Because it says welcome to calculus. I'll put it there on purpose. Learning targets today. Learning targets. I can calculate average and instantaneous speeds. All right? I can recognize when to calculate average or instantaneous speeds. So it doesn't do you any good knowing how to calculate them if you don't know if that's what they're asking for. All right? So let's take a look and let's start. First of all, when I say average speed, what am I referring to? Well, I'm actually referring to an average rate of change. Might be, we will see. But yes, eventually it will be slow. Very good, Iman. Very good. All right. And there is a ratio. In calculus, that's what we use. It's actually written right below there as well, but I want you guys to write it and get familiar with it. Okay? It's the function f with t plus h minus f of t all over h. All right? And then I will explain to you what both of those are. Now, I heard someone ask me, okay, rate of change, isn't that slope? Well, yes, it's actually change of y over change of x. But in calculus, we do a lot of our calculations with respect to time, especially when we implement them in situations. Okay? So instead of x being our independent variable, the one that gets inputted, okay, we use t. So you can consider that change in y over change in x. You know, it's the same thing, and that is slope, isn't it? That's slope. So my change in y is really the change in your function. Okay? When I put in that x, or in our case now, when I put in that t, what's our y value? And that's going to change when our x or our t value changes, doesn't it? And t is just our change in time. So if my time was 1, okay, I'm going to get 1 y value, correct? When I put 1 into my equation. And then if my time changes to 3, will my y value also change? It's like coordinates, right? When you have 2 points, for every x, there's a different y. Otherwise, it's not a function, is it? You want to pass the vertical line test, would it?
Oh.
Or would you not have the same x?
You have the same x.
Very good. Look at you. It's like you didn't take any time off this summer. All right? So let's actually do this. A rock breaks loose from the top of a tall cliff. What is its average speed? Let's talk this way. So what is its average speed during the first 2 seconds? Given the function y equals 16t squared to represent the situation. So we know t is obviously what? Time. Does anybody remember what 16 represents in front of a quadratic? Anybody remember? Well, we used to have a negative 16 in quadratics. And
Oh, wait. No,
right? You guys, I know, it's familiar to you. Remember the free fall quadratic when you drop something 16? That's gravity.
yes.
That's gravity in feet, not in meters. So you're like, oh, isn't it 9.8? That's in meters per second squared. 16 would be in feet. So let's take a look at this. First off, we need to calculate the average speed the first 2 seconds. So my time changes, okay? My time changes from what to what? Time starts at something? It starts at 0. That's when the rock first breaks off from the top of the cliff. And what's my ending time? 2. Yeah. So I'm going to figure out the average speed when that rock falls when it starts to fall to 2 seconds into its fall. I don't know. It doesn't take 2 seconds to hit the ground. Maybe it does. Maybe it takes 10 seconds. I don't care. I just want to calculate the average speed when it first breaks off to 2 seconds, wherever it is. All right? So I know we need to use our change in y over our change in t. We have a fraction. We have a fraction. So let's do the easy part first. How do I set up my change in time? It's just like if you would do slope with points, wouldn't you? What do you need to subtract your x values on the bottom? And now instead of x, we have t. So let's subtract our t values. I always like starting with the bigger minus the smaller. That way I don't have a negative number. It'll make life easier. So now, those are my x or my t values on the bottom. What about the top? I need to figure out what my y is when my t is 2. So it'll be 16, 2 squared. Okay, that's what my y value would be at time 2, wouldn't it? I just put t in the equation. Minus my y value when my time is 0. That's it. So, now these are things you should be able to do without a calculator. You okay? We're good? Super. Thanks for asking. Okay, so what is 2 squared?
4.
What is 4 times 16?
64.
You do that. In the calculator? No, that's good. Yeah, see, these are things when they say you shouldn't use a calculator. You shouldn't need a calculator to simplify this. You're in high school. You can use a calculator to check to make sure that your mental math is right. Okay, so that is indeed 64. Minus what's going to be this. That's going to be 0. All over, what is 2 minus 0?
2.
That's 64 over 2. And that's 32. Can anyone guess what my label is going to be? It is feet per second. Because they want to know the speed. When you drive a car, isn't it miles per hour? And here the speed of the rock is feet. Because did they not put feet in the problem? Oh, that's terrible. Well, I told you this was in feet, didn't I?
Yeah.
So that's the kicker. Whew, I just saved myself. That's feet per second.
Right.
I should get the Jolly Rancher. Me. You owe me gum. That's Brianna. That owes me gum. That's Brianna. That owes me gum. Okay, so there's 32 feet per second squared. That's the average. It's probably going to be going a lot faster at 2 seconds. And at 0 seconds, how fast is it going? 0. It hasn't started to fall yet. So it's going 0, and it's going faster than 32 because I have to take those and I'm going to average them out. So at some point, when I add up all those speeds at all those positions, and I divide it by however many speeds I took, I should get about 32 feet per second. Simple, right? Not too bad. Not too crazy. Now do it on your own. An object dropped from rest from the top of a tall building falls at y equals 16 t squared feet in the first t seconds. Find the average speed during the first 3 seconds. All right, so I checked with a lot of you guys, and 48 feet per second was the right answer. And let's figure out how we did that. So I have my change in y over my change in t. So who can tell me what's going to go on the top? 3.
16.
16.
And
3 squared
minus
minus 16 0 squared. Perfect. Perfect. Bottom, any takers? Brianna.
3
Uh-huh.
minus 0.
Bam. That's it. Simple. Perfect. You got it. So let's simplify this. I know the denominator, 3 minus 0, will be 3. Who can tell me what is 16 times 3 squared? Yeah.
44.
144. Anything times 0 is 0. So we have 144 over 3. And Adrian, you said that comes out to be what? 48. Don't forget your label. Oh my goodness. If I gave an exam and it was 10 questions and you had to answer questions like these and you did them all correct, but you forgot the label for every single one, Let me explain to you what happens. If there was a 3-point question, I would have to take 1 point off of each question. Which means you would have calculated all your math absolutely correct. You just did not write your labels. That means you would have went from 100 to a 66. Because you would have gotten 2 out of 3 for every question. And you got all your math correct. Crazy, right? So that was average speed. Let's talk instantaneous speed. So by definition, instantaneous speed is the speed of a moving object at a given instant of time. Okay, a given instant of time. An instant doesn't have a starting time and an end time. It is an exact moment. That's a difference. That's a big difference. Okay? And look, we have our same little fraction, our expression here, f of t plus h minus f of t all over h. But based on what we just did for average speed, what's the problem with this expression here for instantaneous speed? I'm going to pause it and give you guys a minute to think about it. Okay, so what's the issue with the ratio for instantaneous speed here? The denominator, which is supposed to represent a change in time. When we did the average, wasn't the denominator like some number? The first problem was 2 minus 0 for the first problem. The second problem was 3 minus 0. Because that's, I wanted an average, right? Those went down here. Because I wanted an average from when the rock started falling to 2 seconds later. But for an instant, like right at 2 seconds, 2 is the starting time. 2 is also the ending time, isn't it?
Yeah.
That's an instant. What is 2 minus 2? Can I have a 0 on the bottom? There's the problem. There's the problem. So, there is no change in time for instantaneous. If it is an instantaneous moment, it doesn't start or begin, it is there. It existed back at that one moment. So, we need to try to algebraically remove the denominator, which is our h on the bottom. Okay? We want to try and get rid of that h. Because if I get rid of the h, then there's no denominator, which means 0 ain't going to hurt me. I think when you have a 0 on the bottom of a fraction, doesn't it like rip space and time, the fabric, or creates a black hole somewhere in the universe? That means other galaxies. Life. Hopefully it's with people like me. I'm brilliant. Okay. Yeah. Just think about that for a moment. All right, so let's try this. Let's try this. Let's calculate the instantaneous speed. Okay, so we're going to calculate the instantaneous speed of that rock from the first example. We have that equation y equals 16t squared, where t is 2. Okay? I don't want the average speed from when it first started falling to 2 seconds later. I want the instantaneous speed of that rock right at 2 seconds. We know we can't just plug in because the bottom will give us a 0. So, we still have change in y over change in t, correct? But this is what we're going to do. We're actually going to literally, we're actually going to use that. All right? But I can't put 0 in for h, can I? So I'm going to leave h alone for right now. Follow me? If I put a 0 in for h, I'm screwed, aren't I? I can't put a 0 in for here. Because when something is instantaneous, that means h is 0, right? There's no change in time. I can't make that a 0, won't work. So this is what we're going to do. I know time is 2, don't I? So, when t equals 2, I'm going to start this. I'm going to say, I'm going to take my function, okay, and have 2 plus h. I'm going to put a 2 plus h in the function. Then I'm going to subtract the function with just a 2 in it, because that's my t. You see where I'm getting this? I'm getting this right from here. Okay? In my fraction. I'm leaving my h's alone. And I'm literally going to use that fraction all over. Well, the bottom doesn't have a t. It just has an h, so I'm just going to leave it. Because technically, this is as h is 0. And I can't put a 0 in there, otherwise I am screwed. So let's manipulate this. What is my function? What equation do they give me?
Y equals 16.
Y equals 16t squared. So let's do something. That's the same thing as saying f of t equals 16t squared, isn't it? It's the same thing. So I'm going to take 2 plus h and put it in for t, for the first. Then I'm going to take 2 and put it in for t for the second term on the top of that fraction. Follow me. So I've got 16 times 2 plus h squared. All I did was put a 2 plus h in for my variable into the function. That's what it's telling me to do, put a 2 plus h into it. Minus, now I've got to put a 2 into my function. So now I'm going to put a 2 in here. Minus 16 times 2 squared. I'm only inputting what they're telling me to input into my equation. Yeah, don't start looking at the whole thing. Just focus one at a time. I'm going to put 2 plus h into my function for t, and which I did. And then I'm going to put subtract, putting a 2 into that same function for t, which I did. All over h. Remember, the h's we're not doing anything with. All right? Now here is where our FOILing skills better be darn mad good. If I have 2 plus h squared, I do not just square the 2 and just square the h. That is not 4 plus h squared. I have to take 2 plus h and multiply it times 2 plus h, and I got to FOIL. Okay? Remember some of the shortcuts I told you guys to do? So let's do this. Okay? Going to come down here. I now have 16. I'm going to keep that. I'm going to FOIL. Can anyone tell me quickly what's 2 plus h squared? It's 4 plus 4h. Don't forget the middle terms. Plus h squared. Because I get, if I do this quickly, yes, I added and multiplied. That's how I do it quickly in my head. Well, this is 4, 2 times 2. Then you got 2h plus another 2h. Then you get your h squared. Your 2h and 2h and 4h. Right? Yeah. Minus. All right. 2 squared is 4, and 4 times 16. 64. Very good, very good. It is. All over h. Don't forget, we're not doing anything with h. Now, and you guys can write wherever you want to on your paper. I know. I'm doing this bigger so it's easier for you to see. Let's distribute our 16. I've got 64 plus 64h plus 16h squared minus 64 all over h. Nothing crazy. Nothing crazy. Yes. If you do this right every time, you do this right every time, your first term and your last term should cancel. You have a positive 64 and a negative 64. Now let's take a look at what we have left. I'll rewrite it. Yeah, we have 64h plus 16h squared all over h. What can I do, children? Okay, you can factor an h out and cancel, or you can recognize that if every term has an h, I can take an h out of every term. That's an easier way to do it. So I take an h out of here, I take an h out of here, and I take an h out of here. Now I have 64 plus 16h. Quick reminder, what's my h equal to?
Wouldn't be 0.
H is equal to 0. That's an instant because there's no change in time. Now I can plug a 0 in there, can't I?
Yeah.
Yeah, get excited about it. Okay, 64 plus 16 times 0, bump, 64 feet per second. Now, let's look at this for a moment. The average speed from the time it started falling to 2 seconds was what? The very first problem we did. 32 feet per second. That was the average. But at the exact moment that rock was 2 seconds into its fall, it was going 64 feet per second. And that makes sense. The longer it drops, it should build momentum. It will be going faster. The acceleration, it's increasing. Oh, we'll get to acceleration in a little bit. Start. But for right now, this is velocity. That's the change in rate. That is an instantaneous rate. Right at that moment. Bang. Very good. So, okay.
Yeah.
Okay. Now, the answer tends to change when I say, now you do it. I'm like, wait, mister, no, not okay. Okay?
Right.
Okay.
Okay.
Let's read this and I'll let you guys go off on your own. An object dropped from rest at the top of a tall building, this looks familiar, falls y equals 16 t squared feet in the first t seconds. Find the speed at, not the average, but the speed at 3 seconds. Confirm your answer algebraically, which just show me your work. Okay? This is not average because it doesn't say find the average speed. It doesn't give you 2 times. But it doesn't say instantaneous. So how do you know it's instantaneous? Kind of. Yes. The time is 3 seconds, but they're saying find the speed right at 3 seconds. It doesn't say, okay, what's the average speed from this time to that time? I want the speed right at this moment. That's what tells me it's instantaneous. Good luck. All right. So, doing the same method as before, I'm going to take 16 times t, which is what, 3?
Yeah.
Plus h squared minus 16 times 3 squared all over h. We cannot put a number in for h because it's 0. So I've got 16 times 9 plus 6h plus h squared minus 144 all over h. And if I FOIL my 16, I get what? 144 plus 96h plus 16h squared minus 144 all over h. Again, if we did this right, the 144s cancel. I can take an h out of every term. So I've got 96 plus 16h, where our h approaches 0, correct?
Yes.
Times 0. Anything times 0?
No.
96 feet per second squared. No squared, that's velocity. Acceleration, rather. We want velocity. There you go. You got your 2 problems in the book. Go nuts.